Now today we just want to understand how and what are the factors on which resistance does depend. Okay, so today we are discussing the factors on which R depends, the dependence of resistance on different factors. So that can be understood by using this activity which is shown in the textbook. See this particular diagram activity which is shown, this drawing board is shown, and you put the two pins over here and then gap is left and the wire is being connected by using connecting wire. A battery eliminator, battery key and ammeter is connected in series, and you can see the gap over here. Now what is this being shown in the textbook? If you referred, this gap has shown like this diagram this way, or this particular 3, 4 this way. Now to understand what is the meaning of all this and how do you get the concept of resistivity is interesting. See here just now, see I marked here point number 1, 2, 3, 4. This is what 1, 2, 3 and 4 part means. What we are doing here in the gap, we are initially in the first part we are keeping nichrome wire, and we can just see by connecting nichrome wire what is the deflection shown by an ammeter. Does ammeter shows a less reading or more reading, that we have to record. Then what we do in the next step, we increase the length of this nichrome wire. We are doubling the length of nichrome wire. Okay, so when double the length, what will happen to the ammeter reading? When you do the third part, when you take the same length but the wire is now more thicker, that means its area of cross section is increased. So what will be the deflection shown by the ammeter? That you need to see it again. Then we change the material. Instead of nichrome, now you in the fourth part we replace the material. You take different material. You can take a copper, constantan, manganese, eureka or any material and see the deflection seen by the ammeter. Okay, so that is what the meaning of this 4 part which is shown over here. This is shown separately. Now what happen actually when you keep the nichrome wire here and when you double the length of the nichrome wire? What is observed actually? When you double the length, okay, what do you see? You will see that it is being found that by doubling the length of the wire, resistance get double. You will see a deflection shown by the ammeter decreases. It will show low deflection. Means you will understand the current decreases, means resistance increases. So you will come to the interesting fact, with the increase in the length, with doubling the length, resistance is also increasing. So ammeter is showing less reading. Deflection is seen is low. Third step, what we do? We take the same length but area of cross section is increased. Now we are taking more thicker wire. So if you place a more thicker wire over here, okay, so what is seen in the ammeter deflection, just note down that also. You will see the more deflection of current. That means with the increase of area, resistance is decreasing. Okay, these are the facts which we come to know from this particular activity. Now we see this fourth part. Now in the fourth part we are changing the material. Now you take some other material and see the deflection. Now with this activity we will come to know how dependence of resistance, and even one more factor is there, that is called temperature. How with the increase or decrease of temperature does resistance varies. Now we will see the mathematical aspect of this. Now what are the factors on which R depends? We will easily recognize R is proportional to length. This we are getting directly. With the increase of length we are seeing resistance is increasing. Similarly, if you see in the area of cross section, what is happening with the increase of area, your resistance is decreasing. Matlab, by using Ohm's law, V by I is equal to R. In case if resistance increases, current decreases. Or you can apply this Ohm's law here. If the resistance is decreasing, current is increasing. That is what we have seen in that activity, the deflection seen by the ammeter. Okay, accordingly we get this mathematical formulation. Now you combine these two equations together and you will get one equation is this. This shows how resistance depends upon length and area of cross section. Now replace this sign of proportionality by a constant. This constant is called resistivity of the material, rho. It is denoted by the symbol rho, and this is nothing but resistivity of the material, or this is also the word called specific resistance. This is also the word which is used. Specific resistance we call this, or resistivity of the material.